Hey, welcome back to class. I'm Miss Algebra. Really glad that you could make it. Today, we're going to be talking about one-step equations. And I know that this doesn't generally seem like an Algebra 1 lessons. This is something that normally gets taught like sixth grade, seventh grade, even your pre-algebra classes. But since we're working on like building those algebra foundations, I did want to make sure that I included a lesson on one-step equations just so that we can see how it builds out as we get to more and more complex equations further down the line. So, without further ado, if you have your guided notes, you can go ahead and take those out. If you don't have your guided notes, you can access them by clicking the link in the description below. You can get actually all of the lessons if you want in a bundle. So that's really exciting. All right, let's go ahead and get started. Let me get myself together. All right. So, first things first, we always want to start with our learning target. Why are we here? What are we doing? Today's is I can solve one-step equations using inverse operations. We're going to be talking about inverse operations a lot over the next few lessons. So I do want to make sure that we talk about them and we specify when we talk about inverse operations. A lot of times we use the word opposite or the reverse, but inverse is going to be the most mathematically correct term to use there. So what they want us to do first, we'll jump there. In our do first, they want us to write the inverse of each operation. So I want you to think of the inverse being the operation that like undoes another one. So let's think of undo. Sometimes you want to think of the word opposite, and that's also okay, but I don't like to use opposite since normally with opposites, I'm thinking of like a positive number and a negative number being opposite. So we'll talk about that a little bit later. For now, we're just going to look at the inverse of each operation. Let me give you a second. So I know you know the inverse of addition. You're right. So, right, it is subtraction. The next one may give you a little bit of a hard time. Our operation is squaring. Now, when we square a number, to square a number means to multiply it times itself. And the inverse of squaring is called taking the square root. When we square a number and then we take the square root, we get back to our original value. All right. And then we have division. Division is like repeated subtraction, and its inverse is multiplication. I know you got that. All right. Lovely. Let's move on to the vocabulary. Remember, math is not math unless we can talk about it. So I want to make sure that you know what you're talking about. Here are our vocabulary terms for today. The first one is constant. We talked about constants in the last lesson on the distributive property. A constant is a term with no variable part. So it is just a number. So a term with no variable part. And you can choose any number you want. If you want an example, like example could be 6, is a constant. All right. A variable, we know the long definition, right? It's a symbol. It's usually a letter. We can put a letter in parentheses there. That stands for an unknown value. Perfect. Right. Our next definition, coefficients. Let me see. A coefficient, I like to remember that coefficient starts with CO the same way that constant starts with CO. So a coefficient is a constant, but it's a constant that's multiplied to a variable. So it is a number multiplied to a variable. So in 6x6 is the coefficient there. I use the same number there because I do want you to remember that it can be a constant. And today we are going to introduce a new word. That word is isolate. We're going to be talking about isolating variables quite a bit when we solve equations. And so I wanted to make sure that we included this one. When we are isolating a variable, when we are solving an equation, what we are basically doing is we are kind of just manipulating the equation. We're using the properties of equality. So we're continuing to have these statements of equality, this balanced equation, but we are manipulating the equation so that the variable is alone, which means it needs to be being multiplied by 1, right, to keep its identity, and it needs to be adding 0. So we wanted to make it like the most complex possible. We could say 1x plus 0 equals blah, 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 but it's just x equals something. So I want the variable to not be being added or subtracted from anything else. I don't want it to be multiplied or divided by anything as well. All right. When we come to our big idea, right? Remember that our goal is to isolate a variable when we're solving an equation, and we need to use these inverse operations. So I want to remind you that inverse operations are the ones that undo one another. We talked about that a little bit in the do first, but go ahead and write it here in our big idea. Inverse operations undo one another. Inverse operations undo. You can put each other there. Perfect. All right. Let's take a moment. Let's look at some of our guided practice examples. We have one for each operation that we can encounter. So I want to first, before we get there, sorry, before we get there, let's go to the keep in mind section. Want to make sure that we have a good understanding of what we're doing when we work with our inverse values. So some of our inverse values are going to involve opposite numbers. Opposite numbers are going to be like a positive and a negative. What I want you to remember about opposite numbers is that they have a sum of 0, meaning when I add them together, I get 0. So have a sum of 0. And they give us a space for an example. Let's do -5 plus 5 equals 0, right? -5 and +5 are opposites. When we add them together, we get 0. The next kind of values that we'll have are going to be reciprocal values. So reciprocal numbers, we multiply those together. These have a product of 1, and I'm gonna just write 1 like that. And then for example, we normally talk about fractions when we have reciprocals. So let's say we had 3/8, and this would be times 8 over 3. If I were to work that out, I would get 24 over 24, which is equal to 1. So reciprocal values, when we multiply them, we get 1. If I want to check my answer, and you should always check your answers when you're doing math just to be safe. I make mistakes all the time, so I am not as good about checking as I should be. I will work on that this year. Here's how we solve, sorry, how we check our answer. Whenever you get your final solution, you're going to want to plug it back into the original equation. We call it substitution. So like if I was not in my class, I would have a substitute teacher to replace me for the time being, right? So how to check my answer? I'm going to substitute answer into the original equation. And I'm going to solve it. Again, I should be looking for a true statement. I should get a true statement if that is actually the solution to my equation. My solution is the value that makes any equation true. All right. Now that we have that in mind, let's go back. Let's take a look at some of our examples in our guided practice. So the first one is addition. And when I named these like by operation, I named the operation that you see. So notice that this is addition because the problem involves addition, right? We're not going to use addition. We need to use the inverse of addition so that we can solve this. So right now, 6.2 is being added to x in order to, and it's a little bit weird because 6.2 is like here in the front, we don't see a sign, but we know that there is a positive sign that's being implied there at the front. So because it's being added to x, in order to do the inverse, we need to subtract. Now, remember we said that opposite values have to add to 0. So because we're adding and subtracting, we want the opposite value of 6.2. That's going to be negative 6.2. What I do to one side of my equation, I have to do to the other side of my equation. Remember, the goal is to keep this balanced, right? We're saying that these two sides are equal, so we have to keep doing the same thing to both sides, keep treating them equal, right? This is 0, and I actually like to go ahead and draw the 0 and cross it out so I can see that it's 0. On this side, I'm just going to subtract. So x is equal to 7 minus 2 is 5. Bring my decimal down. 9 minus 6 is 3. X equals 3.5. Beautiful. Again, I can always check it by plugging it back into my original equation. For now, we're just going to go ahead. Our next problem involves subtraction. Really quick, tell me the inverse of subtraction. We know it's addition. All right. This time, our variable is z, and we have z minus 4.8. Notice that it's on this side now. We're going to add 4.8. Again, we want to do the inverse operation. Inverse of subtraction is addition. And we need to make 0. Excuse me. And we need to make 0 so that it's like z plus 0, right? So I'm going to go ahead and add 4.8 because I want to make 0 right there. And I'm going to add 4.8 on this side as well. Is equal to z. 3 plus 8 is 11. I need to bring that. 7 plus 1 is 8. Plus 4 is 12. We have 22.1 equal to z. All right. So that's addition and subtraction. Remember, you're going to have to add to get to 0. Add, put in the opposite so that you can get a 0 pair. Next, we have multiplication. So when we are multiplying, the goal is to have a coefficient, the number that's being multiplied to our variable. The goal is to make that equal to 1. Right now, it's equal to -9. So in order to get -9 reduced to 1 when it's being multiplied, we're going to have to divide since division is the inverse of multiplication, right? So I'm going to go ahead and divide on both sides by -9. A lot of times people forget about those negatives, so be really careful there. And that equals 1. 1w is just w. Now I'm going to divide, and w is going to equal -8. I need to remember positive divided by negative is a negative. In fact, now is a good time to go down to that common mistake box and write, do not forget about your negatives. Don't forget about negatives. And then over here, I'm going to actually draw this little icon that I like that helps me remember like how to multiply and divide my positives and negatives. So it looks like a triangle. And I kind of draw a little section in there. I'm going to put 2 minus signs and a plus sign. All right, here's how it works. Just real quick. I normally like to cover up 2, and then the remaining symbol is the one that I need. So positive divided by negative leaves me with a negative, right? Negative times negative leaves me with a positive, and so on and so forth. This works for multiplication and division only. Multiplication, division only. So if it helps, you can go ahead and write that. Excuse me, I'm a little stuffy. And we're going to go ahead and move on to division. Okay, with division, we have our variable c is being divided by 3. We need the inverse operation. This could also be written as 1/3 c. You may see it that way, but we're going to go ahead and multiply this time just by the denominator. A lot of times people want to go ahead and say, go ahead and multiply by the reciprocal. Right now, for all of these problems, the variable is going to be the numerator. So it's just going to be like a unit fraction. And the inverse of a unit fraction is a whole number, or the reciprocal of a unit fraction is a whole number. So I'm just going to multiply both sides by 3 here. This is going to be 3c divided by 3 is going to be just 1c. So c is going to be equal to 25 times 3. Anytime I have to multiply or divide by 25, I think about quarters. So 3/4 is 75 cents. All right. I think I messed up my colors. I've been going back and forth between red and blue and all kinds of stuff. Oh well. All right, last one, squaring. We talked about this in the do first. We know that the opposite of, sorry, the inverse of squaring, gotta be careful about that vocab. The inverse of squaring is taking the square root. So I'm going to take the square root here and also take the square root of this side. We're gonna step into a little bit of controversy here. R is gonna be equal in this case to positive or negative 11. I need to keep in mind that 11 times 11 is positive 121, and also negative 11 times negative 11 is 121. When we're solving equations, we do want to keep both of our square roots in mind. However, a little bit later down the line in your algebra learnings, you will talk about square root functions. And in those, we don't consider the negative square root. We only consider the positive one. But for now, positive or negative 11. If I only want you to use the positive square root, I will let you know at some point. All right. Moving right along, our try it out section today gives you an opportunity to solve equations and also check your answers. So let's take a look at how we did that. Our equation here was x plus 82 equals 327. This was the work that we did. So we started by making a zero pair right here, and we subtracted 327 minus 82 gave us 245. Remember that you always want to check your answer, and you check it by going back to the original equation. This time, that's not going to make such a big difference for us, but once we get to more complex situations, it's really important that you substitute into the original equation. So I put this here. We want to check x plus 82 equals 327 if x is equal to 245. I like to write this out just so I know what it is that I'm doing. I don't lose track. And then I went ahead and substituted. So notice that instead of x, now I put 245. And I do have to actually write out this statement that says 327 equals 327. So it feels a little bit tedious. It is a little bit time consuming, but it is worth it to check your answers. Okay, it is definitely worth it to take a little bit of extra time on the front end. All right, let's go down first. Let's start here. First, think about the operation that you see. I have 12x equals negative 48. I know that whenever I have a coefficient and a variable, that implies multiplication. So I need to divide in order to solve this problem. I'm going to go ahead, I'll leave it in, let's go back to blue. Why not? I'm going to divide by 12 because 12x divided by 12 is going to give me 1x, right? So there's 1 right there. I'm going to divide this side by 12 also. Need to keep in mind, I have a negative divided by a positive. If I was not sure, I could come back up here. Negative divided by positive leaves me with a negative. So I have that and I'm good to go. So x is going to be equal to negative 4. All right. They want me to go back and check. I'm going to do exactly the way that I said. So I'm going to have 12x equals negative 48 if x equals negative 4. And then I'm going to come down. It's going to say 12 times negative 4 equals negative 48. Again, remembering that I'm substituting this value in for x. So notice that it was x there. It's going to be -4 there. Now I'm going to multiply 12 times -4 is -48. And that equals -48. Again, like I said, it feels more tedious than it actually is. It really, really comes in handy once you start getting more complex equations. All right, we have two more in this section. No, almost done. Jumping up to that top left corner, sorry, top right corner, we have 14 equals x over 4. That fraction could also be 1/4 x. You may see it written like that, so fret not. We just need to get rid of the denominator. Right now, x is being divided by 4. So we are actually going to multiply by 4 on both sides. I'm going to put 4 in parentheses. We know parentheses tells me that we're multiplying. That becomes 4x over 4, which is 1x. And then I have 4 times 14. All right, if I was not sure how to do 4 times 14, I could do, make sure that 14 is 10 times 4, right? So 4 times 10 is 40. 4 times 4 is 16. 40 plus 16 is 56 equals x. And I just want to be sure that I got that right. So I'm going to check it to check 14 equals x over 4 if x equals 56. And I'm going to again come down and now substitute 56 in for x. So 14 equals 56 over 4. And my last line does need to say 14 equals 14. You can check with the calculator. I am not gonna be hung up on you using a calculator. You do get a calculator in algebra class. So if you need to use a calculator for 56 divided by 4, please use the calculator. Okay. Double check with the calculator. Not mad at it. All right, last one involves decimals. I don't want you guys freaking out whenever you see fractions or decimals. They really try to put them in there to make you guys anxious. But you don't have to be. You do not have to be anxious. All right, this time, think about the operation that we need to use here. What operation do we see? What operation do we need to use? So I see we have x minus 13.5. So we're seeing subtraction. And even though I have this negative number here, I'm not really going to worry about that for now. The opposite of subtraction is going to be addition. So I want to make 0 on the side of my equation that has x. So I'm going to add 13.5 because that will make 0 for me. I'm going to do the same thing over here, add 13.5. All right, excuse me. I have x equals, and then technically I am subtracting, but what I like to do is I like to think about whenever I have two values that have opposite signs, I like to think about which side has more, right? So is this more positive or more negative? This one is more negative, so you have -61. So I know that my final answer will continue to be negative. And we just need to know like how much more negative. So I subtract in order to do that. So 8 minus 5 is going to be 3. And then I need to regroup here. 11 minus 3 is 8. 5 minus 1 is 4. So -48.3. All right. Definitely need to check that answer. Again, I'm going to rewrite the original equation. So x minus 13.5 equals -61.8 if x equals -48.3. All right, substituting that back in. -48.3. And I'm going to write it vertically because I'm struggling there. Actually, I'm going to write it like this. Minus 13.5 equals -61.8. Again, you can use a calculator if you would like. I'm just going to come over here to the side. 48.3 -13.5. Because I have the same signs, I can line them up vertically like this and just add them together. I know that my final answer is going to be negative, right? If I spend money and then I spend more money, it's a lot of money that's been spent. So this is a big negative. I should have 8 here. This is 11, 61.8. Cool. -61.8 equals -61.8. That checks out. Beautiful. All right. The last thing, in your own words, I do love hearing your thoughts. Why must you do the same operation on both sides of an equation when solving? And I actually forgot to do something, so don't even listen to me. We're gonna go back. Let's pretend that we were still here. Great job. All right. Last thing. Let's do a little bit of error analysis. Let's make sure that we really understand some of those common mistakes that can be made and how we can avoid them. So as Jessica solved the equation below, here's her equation: x minus 12 equals 31. We get her second step. She says that x equals 19. They want us to identify the mistake and solve the equation correctly. So we know she did something wrong. I'm going to actually start by checking this answer to see what she did, see if maybe we can figure out what's going on. So I'm going to come back. Notice that it didn't tell us that she checked her answer, so that may be what's going on. So let's try this. X equals 19, then we should have 19 minus 12 equals 31. 19 minus 12 is actually 7. 7 does not equal 31. So we do know that she made a mistake somewhere. So it's not the correct answer. I want to identify her mistake. Let's take a look. So we have x minus 12 equals 31. And then it looks like she subtracted 12 on both sides. Ooh, I see it. I see it. I see it. So even though she did the same thing on both sides, notice that these are not opposite values, right? We know that opposites add to 0, but if she does minus 12 and then another minus 12, like she's minus 24, right? That's not where we're trying to go. So the mistake that she made here, go ahead and tell me what, or you can tell me what you think that is in your own words right there. But the mistake, at least as I see it, is that Jessica did not add the opposite of negative 12 to both sides of her equation. Sorry, my handwriting is like slipping in and out. All right, what's it? Cool. So they want us to solve the equation correctly also. So let's go ahead and do that. X minus 12 equals 31. Let's add 12. Sorry, I'm going to do that in a different color. Add 12 to both sides. That makes 0 because we have opposite values now. And we're back to x equals, it looks like 43. Now, just to make sure, sorry, just to make sure that we did this right, I am going to go back and substitute, right? So if I want to check x minus 12 equals 31, if x equals 43, I put 43 minus 12 equals 31. This is 31 equals 31. Perfect. All right. Now that we've done a little bit of that error analysis, let's come back and look at the in your own words prompt. Here it is for today. Why must you do the same operation on both sides of an equation when solving? I don't want to see the answer like what you do on one side, we do to the other side. Like, tell me why that is. What is the goal or what are we trying to maintain when we do that? Want to make sure that you know why you're doing what you're doing, not just the steps, but understanding exactly why you have to take each step so that you're good. All right. Let me know your thoughts down in the comments or in your guided notes if you're filling that out. If you have this activity, you can go ahead and continue on to your independent practice. If not, and you would love to have these materials, like I said, you can access them at the link in the description below. Has everything that you need so that you can follow along. Um, Otherwise, I hope that that kind of cleared up one-step equations a little bit for you, helped get you ready for some of the more complex equations that we encounter in Algebra 1. I will see you next time. Have a good one. Bye.